We have already covered point estimates in previous session. The point estimates don't tell us about accuracy, but in interval estimate we can find the likely error of the estimate as well as the range. So in this session we'll discuss the concept of interval estimate and confidence interval in statistics. We'll solve a problem where we will calculate the confidence interval of population mean when given information such as the sample size, the standard deviation, and the sample mean. Let's check this example. For a population with a known variance of 185, a sample of 64 individuals leads to 217 as an estimate of the mean. To provide the uncertainty that will be likely to accompany this estimate, or to provide a range within which the unknown population mean is likely to lie, we need to find the standard error of the mean. We can do so by this formula of a standard error, which is equal to standard deviation of the population by under root n, where n is the sample size. Let's calculate the standard error. So the standard deviation of the population is under root of 185, that is under root of variance, which comes out to be 13.6. Now we can calculate standard error of the mean, which equals to 13.6 by under root n, that is our sample size, which is 64, and we get 1.7, which is one standard error of the mean. Now we can make an interval estimate using our standard error, and we can say the actual population mean lie somewhere in the interval estimate of 217 minus 1.7 to 217 plus 1.7, that is 215.3 to 218.7. But this is still insufficient information. Next, we need to calculate the chance that the actual mean will lie in this interval or in other interval. From probability chapter, we know that specific portions of the area under the normal curve are located between plus and minus any given number of standard deviations from the mean. In the figure, we see how to relate these portions to specific probabilities. We can apply these properties to standard error of the mean. So we can say the probability is 95.44% that the mean of a sample size of 64 individuals will be within plus and minus 2 standard errors of the population mean. Similarly, the probability is 68.26% that the mean of a sample size of 64 individuals will be within plus minus 1 standard errors of the population mean. Applying this to our example, we can say we are 95.44% confident that the mean of a sample size of 64 individuals falls within the interval from 213.6 to 220.4, that is plus minus 2 standard deviations. Or we can say we are 68.3% confident that the mean of a sample size of 64 individuals falls within the interval from 215.3 to 218.7, that is plus minus 1 standard deviation or standard error. Next is confidence intervals and confidence level. In statistics, the probability that we associate with an interval estimate is called the confidence level. This probability indicates how confident we are that an interval estimate will include the population parameter. A higher probability means more confidence. In estimate, the most commonly used confidence levels are 90%, 95%, and 99%, but you are free to apply any confidence level. The confidence interval is the range of the estimate we are making. Confidence interval expressed in terms of standard error. If we report that we are 90% confident that the mean of the population of income of people in a certain community will lie between $8,000 and $24,000, then the range of $8,000 to $24,000 is our confidence interval. The confidence limits are the upper and lower limits of the confidence interval. In this case, x bar plus 1.64 standard deviation is our upper limit of confidence interval, whereas x bar minus 1.64 standard deviation is the lower limit of confidence interval. Between confidence level and confidence interval. You may think we should use a high confidence level, such as 99% in all estimation. But high confidence levels will produce large confidence intervals, and such large intervals are not precise. They give fuzzy estimates. Let's try to understand this with this statement. I don't know your age, student, but I am 95% confident that you are between 18 and 55 years old. The second statement is, I don't know your age, but I am 99% confident that you are between 10 and 70 years old. And third is, I don't know your age, but I am 100% confident that you are between 0 and 180 years old. So as you are increasing the confidence, the interval is also increasing, which is giving us a fuzzy picture. For instance, 100% confidence has highest confidence level, but it's useless. It is not providing us any insight. 99% confidence is still not insightful. So we see there is always a trade-off which depends on the problem in hand. 95% is the accepted norm, as we don't compromise with accuracy too much. So that was all in this lecture. Thank you.